All right. Well, according to StreamYard, we are live. My name is Nate Shuda. I am delighted to be here with my dear friend, Craig Walls. Craig, how the heck are you, buddy?
I am good, better than I've been over the last few weeks. I'm actually talking without coughing right now.
That is a win. The last time I saw you, there was a lot of coughing going on. So I'm glad to hear that you're on the mend. So and
Yeah, I'm not
I'm
saying I'm
sorry.
not gonna cough, but I might, but I'm not coughing
Well,
up.
see, now you've jinxed yourself.
Yeah.
Now you've jinxed yourself. So there's gonna, you can always mute yourself if you have to cough. We really should have like a cough. See, now you're making me cough. We really should have one of those cough button kind of things, or maybe there needs to be a like a 7-second delay. And so, hello, Rodrigo. Good to see you. Thanks for joining us. Um, so I'm delighted. I assume you're either coming from or going to Disney, although I do know you and I crossed paths recently enough that you probably did not sneak a Disney trip in between.
No, me and my wife were talking about it a few days ago, and
Okay.
we were saddened to realize it had been about a month since we've been to Disneyland.
Oh my gosh. Did they like a wellness check to make sure you two were okay or
No, we've missed longer times before, but yeah, they might check on us after a few more months.
fantastic? Well, I know you and I could talk about Disney for hours, but I'm guessing most people are not interested in that. So I think instead we should go ahead and bring your slides into this picture. And I'm really excited about this because I'm a big fan of Spring. I'm very curious to see what this looks like with AI. And I know you and I were talking in the pre-show. There was a breaking change recently. So like fingers crossed, everybody. This is brand new stuff. So without further ado, I'm going to go ahead and drop out and turn things over to Craig. Have at it, my friend.
All right, thank you. All right, so let's get started. This is introducing Spring AI, and here, before I go on, there'll be another slide later on that covers some of this, but before I move past the slide, just note, if you want to follow me on any of the social media sites, there you go. They're right there in front of you. If you want to see, you can also find those links at my website at habooma.com. And in addition to the social media stuff, there's also links to videos I've done, including one that I just published earlier today, and on Spring AI of all things, as well as links to my books and my speaking schedule and whatever else. So just go ahead and check those out. I'll leave that on the screen for about 3 seconds more and give you a chance to jot it down or take a screenshot. And here we go. We're going to go on to the next thing. For those of you who may not know me, may not be aware who I am Craig Walls. I've been a Java champion since 2021. But the thing is, I've been a Java developer since I think it was Java 1.02, which is back when the biggest and most awesome thing that Java did had Duke. Duke is behind me over here. Had Duke spinning across the browser in an applet, and we don't do that anymore. But that's how long I've been developing with Java. I'm also a Spring developer. I've been on the Spring engineering team since 2010, and not related to this talk so much, but I'm also in my after hours. I can't say her name because she'll wake up. She's behind me over here on the shelf. But I have been one of those developers in my after hours, and I've been a champion of that particular thing since last year. And so I do a lot of things. And lately, a lot of this stuff has brought me back around. In fact, all three of these things have brought me back around to generative AI in some way or another. Speaking of which, maybe you've heard about generative AI. It's kind of all the rage for the last year or so. And really what we're talking about when we're talking about AI is there's a whole field of things that you could talk about when you're talking about AI. We're going to focus on generative AI and what do they call it? Large language models, LLMs, and how we can use those in our Spring applications. That's what we're going to focus on today. And the thing about it is, LLMs, as you probably know, everybody here has probably at very least used ChatGPT at some point or another, or something like it. And what you know is they can answer any question. Literally any question you ask it, they will answer it. Now, that answer may not be that great, but it can answer it. And the term we've associated with when that breaks is called hallucinations, which I kind of think is a weird word to use. It's not even an accurate word. It comes down to this. I think humans do the same thing. In fact, everybody, I don't know everything, but I know a lot of things. And if somebody were to ask me a question out of context, I'm going to try to answer it based I'm going to try to apply a context the best I can. And I may answer the question wrongly because I may have applied the wrong context. And that's essentially what LLMs do. My very first job out of college, I was working for a telecommunications company. And I walked in the door and they said, "Hey, come to this meeting with us." And they were talking for an hour about ATM. And I was thinking they were talking about the place you get money from. When you put a card in, you get your money out. And the funny thing about it is, without any further context, everything they said seemed to work. It seemed to fit money machines. But the truth of the matter is, they weren't talking about ATMs. They were talking about asynchronous transfer mode, which is a communications protocol. And so that was just a small example of how I hallucinated, so to speak. LLMs can kind of do the same thing. So you kind of have to forgive them a little bit because they know more than you do. They know more than I do. And without any context, they don't know how to answer the question. We're going to talk more about context a little bit later and how to provide context so you can minimize or even completely, almost pretty much eliminate hallucinations. But we're going to get to that later. We're going to kind of baby step our way into it. The good news is all the hard work has been done for you already. All the smart people out there who have figured out how to train models and do all this machine learning and create these LLMs, they've already done it for you. So for you, at the end of the day, generative AI is just an API call. It's no different than making a call to any API out there. It's just a REST API call. And so the good news is it's really easy to do. It can be done with Spring's REST template, REST client. It can be done with any HTTP client you want to use. It can be done with curl. In fact, I've done some of this with curl just to kind of kick the tires on it sometimes. You can do it with HTTP IE. You can do it with, if you're using JavaScript, you can use fetch. You can use any of these things to make this work. But you could also use Spring AI, because if you're using Spring AI, you don't have to work with the API at the lower level. You can work at a slightly higher abstraction, and it makes working with it a lot easier. Now, that's what this entire talk is going to be about, is Spring AI. But Nate sort of kind of referenced this earlier. I'm going to bring it up again. Spring AI is still pre 1.0. It is, unless something has happened since I started this talk, it is 0.8.0 snapshot, which means things are going to break. Things are just not always going to work. It's fairly stable for the most part as far as the code that's been written in Spring AI. It's fairly stable, but the API is what I'm talking about. The interfaces you work with, they are not necessarily stable. They are still moving around while the Spring AI team is working on it. And in fact, that's what broke. Less than 24 hours ago, there was a lot of work merged into Spring AI, part of 0.8.0 snapshot. Some good stuff, honestly, really good stuff, but it broke everything. I mean, it broke a lot of my examples that I'm going to show you today. Fortunately, they were fairly easy to update, but just be aware, if you're going to use Spring AI, just be ready for things to break occasionally and for you to have to scramble to kind of get things back together. And the timing couldn't have been worse. I mean, we're 24 hours before I give a talk on Spring AI changes. So we're going to try to make it work. If anything goes wrong today, I'm going to blame it on that, but probably we're going to be okay. So what does Spring AI offer? You want to check this out. You're listening to me talk about it, so you're probably curious, what does it offer? Well, at the very least it offers is text-based generative AI. So you can say to it, why is the sky blue? Or tell me a joke about chickens, or whatever you want it to do. And it is going to respond with text. You give it text, it's going to respond with text. And the good news is it works with a lot of different generative AI APIs out there, including, of course, OpenAI, Azure OpenAI, Amazon's Bedrock, Ollama. If you've not tried Ollama, you got to check it out. You can actually run these models locally on your machine. It's pretty awesome. Vertex AI, which is something from Google, and then, of course, the Hugging Face models. So Spring AI is ready to work with all of these. It also offers prompt templates, because as we're going to see as we work through some of the examples, generating a prompt isn't just a matter of typing some question in there and just hoping it's going to work. That's great for simple stuff. But at some point, you're going to want to fill in the blanks. You're going to want to have some refined template that you present to the AI and fill in the blanks with certain details of what the question is or what the instructions are. And it offers support for that. We're going to get to that. I'm going to show that in the examples today. It also offers these things called output parsers. And what output parsers do is they actually do two things. They can inform the prompt on how it should respond, telling it, don't just respond just randomly. Give it to me in JSON or give it to me in some format that I can understand. And then on the other side of it, after the prompt has been issued and we've got a response back, it can take the output of that response and push it into either like a Java bean or a list or possibly a map of values. It also offers document readers, and the document readers are really cool. Those come into play in this thing called Retrieval Augmented Generation, or RAG for short. And what RAG now enables you to do is give your prompts some context so that the AI is not trying to draw on its entire vast knowledge of what it's been trained with, but instead can focus on specifically on certain things, documents that you've given it, documents that have your information in it. And it supports document readers for just simple text, for JSON, but the more interesting ones are the PDF, or even better, the Tika. It's based on Apache Tika, the Tika document reader. And with the Tika document reader, the reason I'm a big fan of the Tika document reader is because it's able to actually read text, PDFs, MS Word documents. In fact, I've not had a whole lot of experience with this, or in what little I have experience with it, I haven't been successful with. But Tika supposedly can even read and get context out of audio files and videos. I haven't succeeded in that so much, but in theory that it can do that. And so that's the one I tend to lean on the most. But that said, what else we have? Vector store integration. So at some point, you have to provide that context, those documents that you want to read and provide as context to your AI when you're asking a question. But vector stores, well, what they do is they act as a sort of like a search engine sort of. We're going to talk more about those a little bit later, but what they do is allow you to store your documents in them in little like chunks, little sub documents. And then when you go ask the vector store, before you go ask the LLM a question, you ask the vector store, hey, vector store, what do you know about this question? And it's going to provide 2, 3, or however many you ask for, little sub documents, and you're going to provide those in your prompt as the context rather than sending the entire document. And here's an example. I have done a few tests with this on some projects I'm working on. And if I give it the entire text of my book, Spring in Action, it's not going to work, for one thing, because all these LLMs have limits on how many tokens, and tokens they're not really words. They're more like it's a breakdown of the text into little smaller chunks. Not really words, but 4 to 6 or so characters or so. And I'm not going to go into the details of how tokens are determined. I'm going to leave that up to you to learn on your own. But the idea is you only have so many tokens that you can submit in a prompt before it just blows out the prompt and you've given it too much information. And you're going to get exceptions if that happens, and things are not going to work. So rather than give it the entire document, like Spring in Action, or I've also tested this against a few different automobiles, owner's manuals as well, to ask questions about an automobile. All of those are going to be bigger than you can possibly fit into your prompt. And so by storing these little sub documents in your vector store, you can ask the question of the vector store first. It's more than a search engine. And I'll talk more about why that is later on, but it's essentially, you can think of it as a search engine, so that when you ask the question of the vector store, it's going to come back with the sub documents, and then those become the context that you submit in your prompt. And Spring AI comes with vector store integration for several popular vector stores, including a very simple vector store that's not really production ready, but it's easy to use. Chroma is a very popular vector store for working with generative AI. Pinecone, you can even use things like Redis and Postgres, of course, Neo4j. Those are popular databases. You can use those as vector store. Microsoft Azure has a vector store that it offers. And then there's these other two projects called Milvus and Weaviate. Those are also different vector store integration support that Spring AI offers. So you kind of pick your own. Personally, I've actually used simple Chroma, Redis, and Postgres quite a bit. And I've started to use Neo4j a little bit to see how it goes. So they come down to adding a different dependency in your build and maybe a configuration detail, but everything else about it is pretty much the same regardless of which one you use. Okay, but this is great. Spring AI seems to do a lot of really cool things, but what kind of problems does it solve? Well, it can solve simple QA. So you can ask it just a simple question and get back an answer. And for reasons I don't understand, I actually have this slide twice. So I'm going to skip over that. But you can also ask it conversational QA. This is like simple QA, but it's not just a one-shot question. You're not just asking a question and then getting an answer, and then everybody forgets there was ever a question answered. Conversational Q&A allows you to give, as part of the context in your prompt, the past questions and answers. So it's like when you're talking to another human. It would be really annoying if every time you ask them a question, you had to, they forgot everything you had talked about before, because now you can't really use the easiest way to think about this is you can't really use pronouns. Because if I ask you a question like, for example, what annotation would you, this is a question maybe that comes out of the Spring in Action book. What annotation would you use to create a REST controller? It's going to come back with the annotation, or with the answer that the @REST controller annotation is what you'd use. But at that point, I might want to ask, okay, does it offer, or does it support such and such parameter, or what parameters does it support? And the problem is without conversational Q&A, without a memory of what's happened prior to that, if you're going back to just simple Q&A, it doesn't know what it means. But conversational Q&A kind of works kind of the same way that we already talked a little bit about RAG. What conversational Q&A does is it provides the history of the conversation as context for all the future questions in the conversation. It's pretty cool. Kind of remembers where things went. Kind of like talking to a human who doesn't forget everything you just asked it. You can also ask questions about your documents, which is, again, the term we've already brought up, RAG, or retrieval augmented generation. You can also ask questions about your data. Now, the way this is commonly done, we're not talking about your data, not your documents, but your data. The way this is commonly done is OpenAI, as well as other APIs out there, have support for this thing called functions. Some of the libraries out there call them tools, but it's essentially the same idea, where you give context that describes the functions, some function within your application. And a function could literally be a function, if like of a JavaScript function. It could be a method in a Java class. It could be an SQL query, or it could be, any number of things, but it's some function that you provided context with, describing that you can do this. And then when you ask the question, it's going to come back and tell your application, oh yeah, execute that function with these parameters, and then send me the answer, and then I'll form it. The LLM will take the answer you give it and form an answer back, form a response back to you using that data. Now, I'm not going to talk about this a lot today. I do have a cool example I could show you if time allows, but I can't promise you that I'm going to have time for it. But I'm going to try. And if I don't get to it, then I'll try to form a video and put it out later on this. But with that said, let's actually see this in action. Okay, let's see some of these examples, some of these things I've talked about. So I'm going to close my slides out for just a moment. I'm going to scooch them off to the side over here. I'm going to bring in IntelliJ, and I'm going to start a brand new project. Now, I'm not going to do live coding for all of my demos today. Some of them I just don't want to do in front of everybody because I'm more likely to make mistakes, but I will do this one. So I'm going to start a new Maven project. And I'm using Maven just because when I'm live coding, I actually like Maven more. Don't get me wrong, I love me some Gradle, but I don't really care for doing it in front of live audience. So I'm going to call this Spring AI Essential Examples. Everything else here is fine, I'm pretty sure. So we'll go with that. And I'm going to go ahead and pick Spring Web, because I am going to add a Spring MVC front end to what I'm building. I'm going to make this a little bit bigger so everybody can see it. We're going to close that getting started, that help markdown file, because I don't really want to see that. Now, the first thing I have to do is I have to come over here to my POM file, and I have to go add the snapshot dependency. Now, the good news is it looks like Spring AI. I'm sorry, not Spring AI. It looks like Copilot tried to do the right thing for me, but I'm not so sure it picked the right thing. So tell you what I'm going to do. I'm not going to type this by hand. I am going to just copy and paste it from elsewhere. And you have to do this because Spring AI is still in snapshot form. I'm using 0.8.0 snapshot, which means it's not going to go to Maven Central. I'm going to be using the latest and the greatest, which is scary and dangerous when people are watching me, but I'm hoping it's going to work out. But if I'm going to do that, I have to add the Spring Snapshot repository. Okay, so I've done that. The next thing I'm going to do is I'm going to come up here to my properties. And you don't have to do this, but I kind of like this idea. I'm going to add a property called Spring AI version. And I'm going to not be 1.0 snapshot because that doesn't exist. I'm going to do 0.8 snapshot. And the reason I'm doing this is because later on, if a 0.81 or 0.82 or 0.9 or whatever comes out, I don't have to go change all of my dependencies down here. I only have to change it one time. And then I'm going to add my actual dependency. And so the dependency I want to add, let's see if Copilot gets it right. No, it did not. So I'm going to say group ID org.spring framework.ai. I'm going to add Spring AI Essential. No, I'm going to add, and this is the one I have to look at my cheat sheet because it's kind of long and I'm probably going to forget it and get it wrong. So let me make sure I get it all right here. Here we go. Spring AI, Open AI. Now, if I picked Azure and I wanted to work with Azure or I wanted to work with Olama or something else, I would do something different here. But I'm going to be working with Open AI today. So Spring AI, Open AI, Spring Boot Starter. And then I'm going to add version, Spring AI version. Copilot got that part of it right for me. Okay, great. That's a great way to get started. Now, the very next thing I need to do, because if I don't do it soon, I'm going to forget, is I'm going to come over to source, main, resources, application.properties, and I have to set my OpenAI API key. So I'm going to say spring.ai OpenAI key. Now, this is the part where if you're really paying attention and you're taking screenshots, you could get my OpenAI API key and go use it yourself later, and then I have to pay the bill. But we're not going to do that. Instead, I'm going to do this. I already have an environment variable set to my key, so it's OpenAI key, so I'm just going to reference it that way. And that's, even though I'm doing that partly to hide my key from you, I'm also doing that because it's just a good idea. That way my application doesn't know what my key is. I'm not checking my key in the GitHub. I'm just referencing what could be my key in an environment variable called OpenAI API key. Cool. So we've done that. Now let's do some very essential generation. And I'm going to do that by creating a brand new controller. So a brand new Spring MVC controller. We're going to call it joke controller. We're going to do a lot of weird joke stuff for the first part of this session. I'm going to make it a REST controller. And my REST controller is going to handle, let's see, how did I do this? I'm going to do a get mapping for joke. Okay. And then I'm going to take and say string tell joke. I'm going to ask for the request parameter whose name is subject. So we're going to tell jokes about something, whatever that something is. And then this is where it gets a little tricky. So I'm going to take what Copilot said, but I'm going to throw it away. I just need something there so that I get rid of all the errors while I do something else. In my constructor, I'm going to say joke controller, and I'm going to take an object called, and they just changed this. This is one of the things that changed yesterday. It used to be called, no, it's still called chat client. I think it's something else under the covers that changed out from under me. So I'm forgetting. We're all good. It's all going to work. So I'm going to create a field called chat client, and now we're going to be ready to roll. So I'm going to change this to chat client. Oh, here's what I was thinking changed. It's not the name of the class that changed, it's the name of the method. It used to be a method called chat, and now it's a method called call. So I'm going to say, tell me a joke about, and this is not necessarily the best way of doing it, but it's the way I'm going to do it to start with, and then we'll refine it as we go along. So that's it. I have just written a Spring AI application. Now it's stupid and simple, but it'll do the job. Now, what I've done here is I've had it inject the chat client. Where'd that come from? Well, the good news is there's already auto configuration support for the chat client. Now, you could go configure one yourself if you wanted to. That'd be fine. But I don't need to. I'm just going to take the one that Spring Boot has auto configured for me. Now, if everything works fine, and that would be amazing if everything worked fine while people are watching me, but we're going to try it anyway, then I should be able to run this and ask questions or ask it to tell jokes. So let's wait for this to start up. And while we've got a Tomcat started. So far, so good. I'm going to pull my window over And I'm going to use a tool called HTTP IE. I don't know if you've heard of it before. It's kind of like curl, but like for sane people. And it's just a little easier to use. And I'm going to pass in subject equal chickens. And we're going to get a response back. Why did the chicken go to the seance? To talk to the other side. I saw this joke the other day. I think these LLMs only know like 2 or 3 jokes. But there we go. There was a very simple example of how to use the chat client. So that's a very simple essential generation. But now let's take it a step further. Let's use a prompt template. And so I'm going to go ahead and define a prompt template string here. And actually, there's a couple of ways of doing it. Actually, am I going to do it this way? I could do it as a private final static string prompt template equal something like tell me a joke about, and then inside of that, I could say, oops, I lost my cursor. Subject. Yeah, I could do that. That would be fine. I could do that. What I'm more likely to do, however, is this. String. Actually, let's do it this way. Yeah, private string, prompt template. Then I'm going to come down here. I'm going to pass it into my constructor using @value. Say app.prompt template. That's what I'm more likely to do. And the reason is that way I can configure it rather than hard code it. Let's type it the right way, prompt template. And I'll break this down on another line just for readability's sake. And then this.prompt template equal that. Okay, so I'm going to get rid of this. And that's actually not what I wanted either. I could configure that in a properties file if I wanted to, but I'm going to show you another way that I like that's really nice. I'm going to say @value. No, I'm going to go ahead and do it this way. I'm going to do it this way. I'll show you a different way later. Let's see. How about app.prompt template equal tell me a joke about subject. I think I can get away with that. I think that's going to work. And let's go back over to my controller. We should be good there. And so now down here, what I'm going to do is I'm going to say, first off, I'm going to declare a class or an object of type. Sure helps if I could type. Prompt template. Prompt. I'm going to call it PT for short because I already named it prompt template up here. I probably should call that prompt template string. I'm not going to worry myself with that though. And I'm going to pass in prompt template. And then I'm going to say PT dot, and I have a choice of either, I have several different things I could call here, but I can call either create, which creates a prompt object, or I could call render, which creates a string. Either one's fine, but I'm going to choose render to start with. And did they change that on me? I don't remember. Let's see. Render. I think I can do this. Map of subject. There we go. I'm going to assign that to the rendered prompt. And now I don't have to do this weird string concatenation stuff and call rendered prompt. Cool. Let's kick that and see what happens. So I'm going to do a restart. I don't have Spring Boot DevTools as part of my dependencies, so I'm going to do a hard restart. Normally, I would probably do that, but I'm not going to worry about it today. Okay, cool. Let's see if that worked. Let's pull this over. I'm going to clear the screen. I'm going to ask another one. So tell me a joke about, and I did one yesterday that was actually kind of funny. Let's see if I can get it out of it again. What did I use? Porcupines. Now, I'm not guaranteeing it's going to give me the funny joke, but we're going to try. And we're waiting. There we go. Why don't porcupines ever hug? Because they're always a little too sharp. I don't know that that's terribly funny. That wasn't the one I got yesterday. So, but it still worked, even if it's not funny. All right. So there's that. That's using prompt templates. And we're going to see prompt templates doing more than just used for jokes a little bit later. When we get to the RAG example, they become very invaluable, really. But for now, I'm going to just move past that. I'm going to talk about the output parsers. So what I want to do is I'm going to go create another object here. And in fact, it's not another class, not another class, but a record. And I'm going to call it, what am I going to say? joke response. That's what I'll call it. And my joke response is going to have in it the subject and the joke. Just those two objects, or those two records or fields. Back over in my controller, I'm going to take, instead of returning a string, I'm going to return a joke response. And what I need to do is somehow get a joke response out of this. Now, a couple of things I'm going to do. First off, I'm going to change my template slightly. I'm going to come back over to application properties, change my template slightly to put in, not the punchline, but the format. Okay. Just going to simply do that. I'm going to come back over to my controller. I'm going to say, okay, let's do this first. I'm going to use bean output parser. And there's, like I said in my slides, there's 3 of these. There's bean output parser, there's list output parser, and there's also a map output parser. You could also probably create your own if you wanted to get really creative about it. But I'm just going to do this. I'm going to create a bean output parser that is using joke response as its as a thing we're going to bind this to. And I'm going to get the format out of it by saying parser.get format. Down here, because I've already added, as you recall, I've added format to my prompt. I'm going to come down to joke controller and just add format to my set of stuff that I'm rendering into the template. And then, because I'm not supposed to be returning a string anymore, I'm supposed to be returning a joke, I'm going to say this. Let's just get rid of that. Return parser.parse chatclient.call rendered prompt. So far, so good. And I think that's what I want. Let's see. Yeah, now that I've done that, I can get rid of this. I don't need it to remind me. And we'll do a restart. Now, with any luck, what it's going to do, it's going to take my joke response. It's going to use that to generate a format that the response should be in. In fact, just for grins, let's sys out that format just so we can see what it looks like. I'll get rid of that sys out a little bit later, but that way we can see what the format string look like in the prompt. It's going to take that format string. It's going to go put it into the prompt template when it renders the prompt template along with the subject. It's going to send the rendered prompt to the LLM, and the response we get back is going to turn it into a joke response. So let's try it again. Let's pull this over. Let's tell jokes about cats. And you can see down here, this is what the format is. It's giving a JSON schema. In fact, the format goes on to say your response should be in JSON format. Do not include explanations, blah, 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 RFC 8259. And here is the schema that you should follow when you return that. And notice it returned a joke response with a joke property. Why don't cats play poker in the wild? Too many cheetahs. Okay, that's better than the porcupine joke. It's not great, but it's better. And of course, the subject was cats. Cool. So we got that. So what we've done now is we've asked it a simple question. We have asked it a question using just a prompt template. We've asked it a question with a prompt template and also using a output parser to turn that into a bean. Let's do one more thing with this really quick before I move on to the RAG example. Okay. Let's, instead of calling, where am I? I'm looking at the wrong thing here. Instead of calling render, let's call the other one I wanted to call, which was create. I couldn't remember the name of it. Totally blanked on it. I'm going to call create. And I'm going to change that because that's no longer a string. That is actually a prompt object. Of course, when I call rendered prompt is no longer, when I do the call, it's no longer going to return a, what did I just do there? That's not what I asked you to do. It is going to, let's see if I can get this to work out for me. The IDE is somewhat trying to be smarter than me, and I'm going to tell it it's wrong. It's going to return, instead of a string, it's going to return a chat response. So I have to now do something else. Response.get result.get output.get content. Now, there's a lot of stuff in there that we could also get. You notice I went through 3 levels of gets to get to the content. This essentially gets me to where I was before, but why did I do this? It's because there's actually some other stuff in there I want to get to. And I'm not going to dwell on all of it, but one of the things I do want to get to is the usage. The usage is actually kind of useful. So I'm going to just return that, put it in a usage object, and I'm just going to sys out it. I'm not going to spend a lot of time on it. I'm going to get rid of this sys out just so I don't have a lot of noise. But I'm going to sys out the usage. I'm going to use the get. They changed at least Copilot doesn't know what we're doing. There's the prompt tokens. There's the generation tokens, and then there's usage.get total tokens, but that's not what we wanted either. What did it do that? Get total tokens. Cool. All right, I'm just doing that just to show you that it's going to show me how many tokens were in the prompt, how many tokens are in the response, and the total tokens. These are the things that count against you when you are using the API. This is what you get billed on. And it's actually not that expensive. I'm using, the model I'm using right now is GPT 3.5 Turbo. I more often than not, I use 3.5 Turbo 1106, which is not only seems to be a little bit faster, but also allows for more tokens in the prompt. But let's try it, and then I'll talk more about that. So let's ask about alligators. Why don't alligators like fast food? Because they can't catch it. I asked the same question yesterday about crocodiles, and I got the same joke, only it was crocodiles instead of alligators. Again, I don't think LLMs know that much. But down here, you can see, of course, the prompt tokens and the generation tokens add up to the total tokens, but we only have 129 prompt tokens, 32 generation tokens. You can have only so many tokens in your request. With GPT 3.5 Turbo, it's 4,096, basically 4K tokens. With GPT 3.5 Turbo 1106, which is the newer model that they haven't made the default yet, you can have 16,000 tokens. So this kind of determines how much you can send in and how much you can get out, but it's also what you get billed on. And without going into all the details about it, I'm spending, for every 1,000 tokens I use, it costs, as far as prompt tokens are concerned, it's $0.0015 dollars, so basically less than a cent. And for every generation token, it costs $0.002 dollars. So they don't add up fast, but in a production app, especially a production app that may be popular and used a lot, you're going to get a bill. Just to put it in perspective, I threw $15 at this several months ago. So I have a buffer in my OpenAI budget that has $15 in it. I've used like 8 of it in the last couple of months, and about most of that was actually in the last couple of days when I was doing some image generation. So it does, it adds up, but not that fast. And I do this, like, I'm working with this almost every day. So, but again, a production app might burn through that cache a lot faster. So you want to kind of control how many tokens you use if you can. You also, if I was using a different model, like the GPT-4 model, that's going to cost more. It has a higher basis. I don't remember how much it costs, but it's more. The image generation one costs about, if I'm using the DALL-E 2 model, it costs about 2 cents an image. If it's the DALL-E 3, I haven't done the math on that, but I think it's something like 5 or 6 cents an image. Just rough ballparking it there. So you want to be careful with how much you use it, or how much you throw at it. Otherwise, you could get a hefty bill and go broke, and we don't want to do that. All right, with that said, let's talk about the next thing in line. And we've already done this. The problem is simple prompts aren't always sufficient. As I've said already, the LLM knows a lot, but it may not know everything. And that's actually both, knowing a lot is kind of a good thing and a bad thing. It's bad because it's training. Being knowledgeable about a lot of different things is one of the things that leads to hallucinations, because without context, it doesn't always answer the right thing. It's also, it may not know things that you want it to know. For example, I've tested this sort of thing with board game rules. I'm a big fan of playing tabletop games. board games. And while the LLMs usually know, maybe have heard of some of the more popular board games, there's other board games they have no idea what I'm talking about. And so at best, if I'm lucky, it'll tell me it doesn't know. But sometimes it just makes up rules. And that's even worse. And so it doesn't know everything, but it knows a lot, and that gets in its way two different ways. So there's a couple of patterns we can apply here that provide some help and provide context. One of them I've already talked about a little bit is conversational memory. Now, I'm not going to show you a demo with conversational memory today, just not going to have the time, and I don't have an example baked up ready to show you. But the idea here is, rather than ask a question, get an answer back, and then just forget about it, and then ask a new question and get a different answer back, conversational memory remembers the entire conversation, or at least a good chunk of the conversation, and it provides that as context for every question you ask after that, so that now it can remember what we've talked about, and it keeps that context to kind of stay on subject. There's also, I talked about it briefly, functions and tools. Functions are a way to basically describe some function to the LLM as part of your prompt, ask it a question along with that, and then the LLM, instead of giving you an answer back right away, is going to come back with instructions on how to invoke that API or make that query to your database or whatever it is to answer the question. And then you're going to go do that yourself. And the reason you have to do it yourself is because if the LLM were to call it, that's a security concern. There is all sorts of mess that could be created if the LLM had to know how to access your API or access your database. And so instead of the LLM asking the question itself, instead of the LLM going to the API or to the database itself, it's just going to tell you, hey, make this call. Here's the parameters you should give it. Let me know what your answer is. And so you make the call, you send it back to the LLM along with the original question, and then now it's going to take that information and form an answer back. Then, of course, we've talked about RAG, Retrieval Augmented Generation. In this case, what we do is prior to coming to this slide, prior to this picture here, this vector store down at the bottom, we have loaded that up with documents. And maybe it's all the design documents from your organization. Maybe it's all the rules for every board game in your board game collection. Maybe I've tested this with, again, automobile driver's manuals or owner's manuals. I've tested this with my book, Spring in Action. I have also tested this with my favorite one, is the 2023 NFL rulebook. And you can ask it questions about anything. And what happens is, when the question comes in, the application first asks the vector store the question, which is it's not going to give you an answer back, really. It's just going to give you the documents, the little sub-documents, the little document nodes that seem the most relevant to the question being asked. And then it's going to pass it on to the LLM as context along with the original question, and then it'll give your answer back. Essentially, you can think of it this way. It's like you're giving the LLM an open book exam. But even better than that, it's not an open book exam. You've torn the pages out of the book that have the answers on it and said, here's the question for you. The answer is on these pages. Give me an answer back. And that's how RAG works in a nutshell. Now, I'm going to show you a RAG example here in a moment, but on this next slide, just to make you aware of it, there's this kind of mix of conversational and RAG, conversational RAG. It works kind of the same way. So you can think of this as as a mashup of the last two slides. The big difference is if you send both the document context as well as the conversational context in your prompt, when you send it to the LLM, you've given it a little too much information. And you got a couple of problems. First off, you might run out of tokens. That's the first problem. Second problem is, even if you don't run out of tokens, it's going to cost you more. The cost for that prompt is going to be greater because you have more tokens in there. But even perhaps worse than that is, in the course of that conversation, you may have taken a few different turns along the way. And not every part of the conversation necessarily was relevant to the discussion or to the current question. And so what we do is we actually make two requests. We do, first request is, hey, simply take the question we have as well as the context, the historical conversation memory. Hey, LLM, take this question along with this conversational history and generate a standalone question. Basically, It's a little more than this, obviously, but the simplest way to think about it is go and replace all those pronouns with the actual nouns that go behind them, so that now we know what we're talking about. Of course, it can do more than that, but that's the easy example of what to think about. And now that we have a standalone question, we're not even going to send the conversational context to the LLM anymore. Instead, we're going to take the standalone question and we're going to send it along with whatever documents are relevant to that standalone question to the LLM to provide the final answer. And I've seen this pattern used in a couple of different places, most notably the Python and JavaScript version of LangChain provided out of the box. Spring AI does not provide it out of the box, but I have implemented it with Spring AI pretty easily. All right, so vector stores. I've already talked about this briefly, and I'm going to show you an example. Vector stores, they're not just text search, but if it helps you sleep at night, vector stores are a search engine. They're like Google to some degree. You feed them some text, and they come back with things that match that. It's actually better than that. It's actually more smarter than that. In fact, if you want to know how it works, it's this thing called cosine. Cosine difference? And if you want to know how that works, well, it comes down to this is the some of the math that's done. And the good news is you don't have to know this. If you want to know this, if you're excited about this stuff, if you geek out over this, sure, go check it out. But at the end of the day, don't worry about it. It's going to work even if you don't want to do the math. You just send it in some text. It's going to come back with the most relevant documents fitting the question being asked. And then those are the things going to be sent to the LLM for generation. So let's take a quick look at an example that I have for that. I have to go open it. So recent projects, Spring in Action AI. By the way, this project that I'm about to show you is on GitHub right now. I'll give you the link to it a little bit later so you can try it out yourself. But for now, let's see what we got. All right, so I'm going to run through the code very quickly and kind of show you the highlights of it, and then I'll run it and show you what it can do. So first off, just the simplest things to show you is I do have a question record that simply is a mechanism by which I can carry a question into my controller. Rather than passing it in as a parameter or something like that, I have an answer, which is sort of the opposite, but on the way out. And I could certainly throw more stuff in there, like maybe how many tokens were used. But for now, I'm just showing it. I'm just returning the answer. My controller itself, it takes a couple of things as through its constructor. It takes the chat client, obviously, just like we did in the previous example. It takes the vector store, and then it stores those away, and we're going to use them down here. The other thing it does is I've extracted my prompt template into a resource. So I said earlier I was going to show you something, and I decided I'm going to show you that thing later. Well, here's what I'm showing you later. Rather than hard code it, rather than set it in my application.properties, I've just shoved it over into this prompt template. So here's the prompt template. It says, you are a helpful assistant. Let's see if I can see the whole thing. You are a helpful assistant conversing with the user about subjects contained in a set of documents. Use information from the document section to provide answers. If unsure or if the answer isn't found in the document, simply state that you don't know. This is probably the most important sentence in this entire template, because what it says is don't make up stuff. If you can't find the answer in the documents that you've been given, don't make up stuff. Just simply say you don't know. Otherwise, it'll sometimes try to answer anyway. The only time I've ever seen this not work is if it comes back. It may come back and say, well, the documents didn't say this, but I happen to know that, and then it gives me an answer anyway. But that's only happened a few times, but usually it's pretty good about just saying, I don't know. And of course, here's the placeholders. This is the question. This is where the documents that we find from the vector store is going to go into the prompt. Now, I've got an extension called ST. This is not small talk. It's ST because it's based on something called a string template. So I just called it ST for short. Cool. Down here, when I'm asking the question, I'm doing a couple things. First off, the first thing I'm doing is I'm asking the vector store to do a similarity search for my question. It's kind of, let me see if I can break that up on another line so it's easier to read without scrolling. First off, I'm getting my question out of the question object. I'm creating a search request for that question, and I'm asking it to give me the top two documents that match. And the reason I picked 2 is because I'm using GPT-3.5 Turbo. And if I choose 3, I could probably get away with it. Starting around 4 or 5, I start running out of tokens. If I were using GPT-3.5 Turbo 1106, I could probably bump up that number quite a bit more because it has a higher token limit. But here, I'm just going to ask it, give me the top 2 documents that are most relevant to the question being asked. Then I say, okay, based on those documents, I'm going to basically just get the content out into a list of strings. I don't care about the document object so much. I just want a list of strings. And then I take that rag prompt template that I showed you in the ST file. I plug in the input, I plug in the documents, and then I create my prompt. I issue my prompt. Starting about here is actually starting about on line 42. That's very similar to what we did with the joke controller at this point. I send the prompt, I make the call, I get the response back, and I answer. Okay. All right. Let's see, is there anything else worth talking about? Application properties. Oh, I am using 1106 here, so I could bump that top K. I could bump it up a little higher, but just so you know, this is how you set the model that you want to use here, GPT-3.5 Turbo 1106. And now the resource I'm asking for, that's kind of important. Let's go back. I forgot to show you this. Down here, I am actually in a I'm creating a bean called Simple Vector Store. Most of the vector stores, for example, the Chroma Vector Store has auto configuration, so you don't have to do anything with this. But with Simple Vector Store, it doesn't have auto configuration for good reason, because if it's part of the main project, and if it did have auto configuration, it might just enable it for you automatically, and you don't even want it. It's not really a production-ready vector store. It's mostly in memory, although it can be persisted. And I just realized I am persisting it to temp vector store. So bear with me for just a minute. I'm going to show you what I need to do to make this work. This is in the README. When you go pull this out of GitHub, the README tells you to do the same thing. I'm going to delete that, because if I don't delete it, what it's going to do is it's just going to use the one that's already there, which is actually a good thing. But since I've recently changed the resource I'm drawing from, it may or may not, it may use what I had in there before. So basically what I'm doing, a lot of this code here is just simply saying either use the existing vector store if it already exists, but if it doesn't, I'm using the Tika document reader to read. And I call this PDF resource. I probably should rename that because it's no longer a PDF. I could actually pull any document, and I chose in this case to pull the web page from Wikipedia about checkers. And so I'm asking about the game of checkers. I'm pulling those documents in, I'm splitting them up using a token splitter so that I don't have one big document. I can have several smaller documents, although in this case, I think I only get one document anyway. Excuse me, because it's a fairly small document. But if it was like my book, Spring in Action, it's going to create like 100 and something different sub-documents that it's going to throw in there. It's going to split it up into several sub-documents. I'm going to throw that into the vector store, and then I'm going to save the vector store to wherever the vector store goes. So cool. I'm going to ask it about checkers. All right, let's give this a spin and see what happens. All right, waiting for it. And while we're waiting, I'll pull my window back up. We'll clear this out. I'll go ahead and start typing the, it's already ready before I got there. No, it's actually calling the embedding client. So each document, actually the checkers page did split up into several documents, 13 chunks to be specific. Cool. So I'm going to ask, and the question I'm going to ask is something very simple. How many pieces are used? And it's going to say American checkers uses 12, Italian draught uses 12, Gothic checkers uses 16. Cool. And maybe I could ask another one just for fun. How do you crown a piece? To crown a piece in checkers, you move one of your pieces to the last row on your opponent's side of the board. Once there, the piece is crowned and becomes a king, granting it additional movement capabilities. And I could ask it more questions like, well, what kind of additional movement capabilities do kings have, or things like that. But you get the idea. It took my question, it plugged it into this template, which is, just as for a reminder, it plugged my question in right there. But before it did that, it also sent my question to the vector store, got the top 2 most relevant chunks or sub-documents, plug those in there, and then that's what I'm asking questions about. Not asking the LLM what it knows about checkers. I'm asking the LLM to answer the question based on what is plugged in right here. Pretty cool. I think it's pretty awesome, honestly. Now, let me try one more thing. And I don't know if this is even going to work, because quite honestly, it's been a couple of days since I've tried it. But hey, you know, that's what live demos are for. is, oh, actually, I'm not going to show you that. I'm going to show you the image generation stuff. I'm going to save that for later. I was thinking I'm going to show you one where I've done some SQL work. And what I've done is I've given it a database schema. I don't have that example handy. I thought I had it in my history, but I don't. But I'll tell you what it does. Essentially, it works like RAG, but the difference is instead of giving it documents, I'm giving it a database schema, the DDL for a database. And I'm saying, here's what the database looks like. And then I ask it a question, and it forms the SQL necessary to go pull that data out of the database. And then what's really cool is the next trick in that, the next step in that parade is pretty obvious. Issue that SQL to get the answers back. It's kind of awesome. All right, let's go back to the slides. And I'm going to answer the last few questions I have on my slide, but what about this? What about other Gen AI libraries like LangChain, Llama Index, Semantic Kernel, LangChain for J, etc.? Actually, I've tinkered with all of these, and they're all great in their own way, and they're all awesome. LangChain and Llama Index specifically, they're primarily JavaScript and Python. So if you're JavaScript and Python fans, know that LangChain and Llama Index are there for you. And they're both great in their own ways. I kind of like them both for different reasons. Semantic Kernel comes from Microsoft. It is available for, obviously, C#. It's also available for Python. And it's supposedly available for Java, although their documentation doesn't talk about the Java stuff as much as the Python and C# stuff. And I gathered that the Java one's not quite as baked as the other two. And then there's LangChain for J. Why didn't I mention it when I talked about LangChain? Well, because honestly, LangChain for J probably, at least in my opinion, that the project leaders for LangChain for J may disagree with me on this, but from my perspective, LangChain for J is like LangChain in name only. It's very different from LangChain. And LangChain for J is another Java project. It's available for Java. It's another project similar to Spring AI. Works great. I've done some stuff with it. I like working with it. But I'm also, and LangChain for J also has great Spring Boot integration support. I'm going to be totally honest with you. It's really good. It does some really cool stuff. I'm being a part of the Spring team. I'm sort of rooting for Spring AI, but all of these are great in their own way. So definitely, if I were you, check them all out. Still check out Spring AI, of course, but check all these other ones out. They're all great in their own way. What about image and other generation? And that's what I was going to get to in my example. Image generation, video generation, voice, like generating some audio files where it speaks to you, or the other way around where you can submit an audio file and get a transcription from it. What about those things? OpenAI and other APIs out there support those kinds of things. I've done some stuff with, specifically, I've done some stuff with the Whisper API to do transcriptions. I've done some stuff with their text-to-speech to come the other way around and have it speak. I'm always a big fan of talking. I mean, I like working with Alexa. I like working with that voice assistant whose name I'm not going to say out loud. But I love that kind of stuff. But I'm also a big fan of voice technology in general, and you can achieve that with Spring AI, or at least you can achieve that in Java using the Whisper API and the text-to-speech stuff. As of right now, Spring AI does not support these other kinds of generation. Other than, as of yesterday, we have image generation. And the good news about the image generation stuff, aside from the fact that it's really cool that we can generate images now, the other side of it is that it's the work that was done to support that in Spring AI actually set the stage for these other kinds of generation. Even though the other kinds haven't been implemented yet, it sort of set the foundation so that we can build those other things in the Spring AI. So hang tight, though I'm sure those things are coming at some point. But for now, let me just give you a quick demo of what that looks like, and then we're going to wrap up. So make sure that we're not running anything anymore. I stopped my application. I'm going to open up the image gen stuff. Now, this is fun. I actually posted a video to YouTube, and I tweeted and posted on social media about it earlier today. Why didn't it open the project? That's annoying. Do I have it minimized down here already, maybe? I don't know where it went. That's weird. Why is it not opening it? I'm not going to worry about it. If you want to see how that works, I actually have a video, like I said, I posted on social media and how I did it and how I built it. Essentially, the punchline is the code looks like this. It looks a lot like this. And I generated some images. One of them was really weird, but the other one was actually pretty good. And then the thumbnail image for the video was generated with this exact same code. And it was actually awesome. So check that video out. There's probably a tweet going out right now. I scheduled one earlier in case you missed it. It's probably going out right now. So if you're following me on the social medias, then you're going to see that tweet. Go check out that video. Meanwhile, we're done. We're almost done. I just want to mention this. Here's where you can get the code. You want to see the code for this stuff? Here's where you can get it. The RAG example is already out there at this URL. Feel free to go check that out and try it out for yourself. The one where I ask questions about checkers, it's already out there, and you can go change that resource to point to any document you want and make it work. In fact, I've only had one document that I pointed it at that it simply did not work for, and it was the PDF for a game called Burger Battle. I don't know what's wrong with the PDF. I don't know what about that PDF makes it not work, but it refuses to read that document for some reason. I'm sure it's something about the formatting in there. I don't know, but here, it's not really good news, but here's at least the kind of comforting news is that LangChain's PDF readers don't work with it either. So it's something about the PDF. It's not Spring AI that's having trouble. And then for the other examples that I did earlier, the joke example, those are going to be at Spring Essential Example. That's where I'm going to put it. It does not exist yet. It's not in GitHub yet, but shortly after this is over, maybe a little later tonight, depending on how things go, I will push it out to GitHub a little later today, and you can find it there. So take your screenshots now of these URLs and check them out. All right, with that said, here we go. 3, 2, 1. I'm going to make this screen go away. And thank you. I hope you enjoyed the session. I hope you learned a little something from it. I hope you're excited about AI and generative AI, especially generative AI with Spring AI. I hope you're as excited about it as I am. Once again, here's where I am at on the socials. Here's where I'm at on the internet, and check out my books. They're good books. I hear people tell me, and none of them cover the topic of this talk, but hey, they're still worth checking out. So again, that's it. Thank you very much.
Awesome. Well, thank you, Craig. So I see Deshaun who joined us and made several comments as we're going along. So good to see you virtually here, Deshaun. And he did put in a plug for your book. So that is fantastic to see as well. There were a couple questions that came in as you were going. Unsurprising. I have to kind of scroll back up here and find them. Where did the first one go? This is a good one. So Eric asks, is Spring AI using its own implementations to talk to things like OpenAI? Does it sit on something else, aka LangChain for Jay?
No, it's primarily sitting on top of it's the own Spring stuff. I believe it's using REST client in some places. I know initially I think it was using the REST template more than anything, but I did notice yesterday what I think is some REST client stuff going on in there.
Okay,
it's been a moment since I've looked at the inner workings of it, but it's certainly not sitting on top of LangChain for Jay or anything like that.
Yeah. Yeah, Deshaun makes a good point about this sort of being like Spring Data in that it gives you that abstraction on top of those.
Exactly. In fact, I was chatting with Mark, who's the project lead for Spring AI, and he said exactly the same thing, that he thinks of it as being like Spring Data.
And then let's see here. Those were banned. I thought those had been removed. Apparently not. Yes, there was also a good point about tacos being a common feature in.
Thank you, Bill. Hello, Bill Fly. I know you.
Exactly.
And you know I like tacos, and I'm sure you like tacos too.
And I think Deshaun and Bill became good friends. I believe we answered this one. Yes, the code is out there or will be out there shortly.
Yes.
And then let's see, was there one? Here was another question around embeddings. Is that part of application startup, or should we do it on the first hit? Is there some custom way?
No, I would do it. Honestly, I did it kind of as part of my example code in all as one part of the same application, but in a real world scenario, I probably wouldn't do that. And the reason for it is, first off, you don't want to, it's going to slow down your application startup time for one thing. And there's no sense in creating the embeddings every single time you start up your application. That's absurd. It's going to be slow, and it's also going to cost you because hitting the embeddings API costs money too. Now, it's actually cheaper than using the GPT models. It's still like I think it's a whole order of magnitude even cheaper than the GPT models. So it's like pennies of pennies. It's like really small, but it still adds up, especially for large documents, especially if you have a lot of documents. So what I would probably do in those cases is I would probably think of something like maybe a Spring data flow, or some similar, or maybe something similar to that, some pipeline that basically watches some location. It could be a directory, it could be a website, it could be whatever, but it watches some location, and when documents arrive in that location, it slurps them up, it sends them to the embeddings API, and then it drops them into a vector store. And then that vector store is there permanent. It's living all the time. It's not using simple vector store like I did. It's probably using something real like Redis, Postgres, Chroma, Neo4j, something like that. And so those are there. They're always there. And then your application just simply uses it. Your application is not responsible for loading those documents.
Yep. Excellent. So I would second this as well from Deshaun, that the Alexa work is top notch. And I'm wondering how many times I can say Alexa before I'll actually trigger your Alexa. But
I'm surprised.
perhaps she's trained just to listen to your voice, and Alexa won't listen to me. It's always possible.
I'm really surprised that between you and I saying her name a few times, it hasn't happened yet.
Awesome. Well, I don't see anything else here other than folks saying things like great session and thank you and things of that nature. So I think we can declare victory, my friend. And I want to thank everyone who joined us here today. I think this is very exciting stuff, and I'm sure it's only going to continue to get better and better.
Yes, it is. I mean, we're really, to be quite honest, the Spring AI team is just getting started.
Yeah, I think that's a great point, that we should expect some change here. Again, it's 0.08, so this is 0.8, so we're pretty new here. Let's consider that as we're playing around.
Right.
All right, well, thanks everyone. Enjoy the rest of your day, and we'll see you at the next session. Cheers.